Hello and welcome to the Omnex webinar, the new ISO 26262 FDIS second edition, changes and highlights. Today's webinar will be presented by Chad Keimel, Omnex CTO and founder, and Greg Gruska. Greg Gruska is the Omnex champion for APQP, PPAP, FEMA, ISO 26262, Lean Six Sigma, and is a fellow of the American Society for Quality. Greg was a writing member of MSA, SPC, FEMA, and eFEMA manual subcommittees of the American Automotive Industry Supplier Quality Requirements Task Force. Take it away, Greg.
Thank you, Miles. So this is we're going to be talking about the ISO 26262-2018 FDIS. It was out there. It has been gone through voting and is expected to come out shortly. There is some editorial types corrections that they need to make, not functional corrections. So what we see in here is pretty much what is going to be published as the next version of 26262. A little something about Omnex. We've been in the business in our international consulting, training, and software development since '85. We've been in different domains as well as different standards. We are involved in many of the development activities of the standard. I'm not going to be going into a whole bunch. You will be able to see this when you download the presentation. We are located in Ann Arbor, but we are international in scope. We've got offices or resources around the world. We do have some major areas in the Far East and Europe. We are less in the Southern Hemisphere. We are going to be talking about the 26262 second edition. What are the changes and the highlights? We are assuming that you know something about 26262 because this is supposed to be the changes. We're not going to go into the fundamentals of it. We're going to be talking about what is different between the 2011 version and the 2018 version, at least the major. On the whole, it has the same focus. And the 2018 has the same focus as the 2011. Both of them still have the V model, overall V model. One of the differences is that in the 2018, we have the acknowledgement that as one of the development tools that you can use specifically in software is Agile, the Agile approach. This was essentially not inconsistent with the 2011 version, but everybody, when they immediately saw the V model, they immediately took it as the waterfall approach, and they started saying, well, you can't use the Agile approach, which a lot of companies are using. And so the standard actually addresses that. Also, you have not only the V approach for the overall system approach, but also for the hardware and the software. So let's take a look at the specifics. We have, like 2011, we have the functional safety management system as part 2. This has been beefed up a bit. It includes some of the clauses that used to be in parts 3 and 4, and we'll talk about those when we get to the specifics of the different parts. Item definition, HARA and the functional safety concept in the concept phase One of the things you may notice that in here is that we only have 3 clauses, whereas in 2011 we had 4 clauses. We didn't lose the information in that clause or the requirements. Those just got shifted over to Part 2. Part 4 was from 7 clauses, we're down to 4. Again, we didn't lose the requirements inside those clauses. They just got consolidated and or moved to Part 2. Part 5 is pretty much the same way it was before. There are some minor modifications. Same thing with Part 6, the software safety concept, as well as the hardware-software interface. The overall standard on these parts are pretty much the same. One of the things that in Part 7, it has been expanded to include planning of the Part 7 activities. Those were kind of embedded in the other clauses, but these have been pulled out. So now we have 3 clauses in Part 7. Part 8 pretty much is the same, but we do have 2 additional clauses, Clause 15 and 16, which are specifically for truck and bus. The Part 9, the ASIL-oriented and safety-oriented analysis, does have some additional detail, but pretty much the same as it was before. Part 10 is guidelines. It's still informative. This is where it contains the safety element out of context, but it does also include additional discussions and details to help you with the rest of the standard. Now, we do have 2 new set clauses, or 2 new parts. We have Part 11, which deals with semiconductor. This is an informative or guidelines to for semiconductor. Semiconductors are subject to the standard as it is, but this part provides additional information on how you can apply it to the semiconductor industry. Part 12 is the motorcycle. With the motorcycle, you have to do different tailoring, and what this section is essentially the interpretation of the clauses 3 through 9, but put together. There are a lot of things that are overlapping, but there are some uniquenesses specifically in the relationship to the HARA analysis and the identification of ASILs on it. So let us go through and take a look at each of these individual parts, take a look at some added information, what is new, what is different. Okay, so we're going to go through each of the 12 parts. So part 1 is the vocabulary. One thing I've noted about the standard is that it does use terms differently. So even though you feel that you may know all the terms, you would still highly recommend that you get the part 1. The part 1 in 2018 does have added and detailed terms. For example, it defines the dependent failure initiator, which was not there previously. And it clarifies fault-tolerant time interval, including the emergency and interval and so forth. So it goes through a whole lot on that. It defines, has definitions specific for truck and bus. Truck and bus is a new addition to 2018, and so there are some uniquenesses with respect to truck and bus. It also has defined terms specific for motorcycle and abbreviations specific for semiconductor. So truck and bus, motorcycle, and semiconductor are the expansion from 2011 to 2018. 2011 only looked at serial production vehicles under 3,500 kg. That's been tossed out. Part 2, the management of functional safety. We still have the same 3 clauses, except we now include the impact analysis, which was moved from Part 3, which was known as the initiation of safety life cycle, clause 3.6, into Part 2. It is put under the project-dependent safety management. The impact analysis determines whether it's a new development or modification, and which has always been the purpose of the initiation. But the impact analysis now requires a confirmation review, and it's a I3 level confirmation review, which means that it has to be independent of the people who are doing the actual development of it. Assessments and audits are better explained. Assessments are now recommended for ASIL A, where before it was a neutral, and it is required for ASILs B through D. The assessors need to certify compliance to the goals of the standard, and specifically in Part 2, Annexes C and D describe the process of assessment. One of the things that is clarified is assessors are allowed to have assistance without independence. Now, the purpose of the assistance is so that you could have a person who is doing a functional safety assessment in the past had to have subject matter expertise. Here we could have somebody who does not have full subject matter expertise, but could have somebody along with additional knowledge. Communication between cyber physical security specialists and safety specialists must be included in the planning. It doesn't say that the 26262 is going to be involved with cybersecurity, but there needs to be the overlap, because you could have quality or safety requirements which could impact cybersecurity and conversely. And cybersecurity we do have an SAE standard, J3061, and there is being developed an international standard which I understand is based upon 3061. And finally, release for production was moved from Part 4 to Part 2.
Greg, question on confirmation reviews.
Yes.
That table. It looks like a lot more confirmation reviews have been added, unless I'm mistaken, looking at the table.
Yes, in fact, we do have a couple slides that actually talk. This is the 2011 confirmation measures, and so we have the different measures, and notice it's only A through D. It also has things like software tool qualification in there. And now let's look at it from 2018. Yes, there are more. We don't have the tool qualification on there, but we do have safety analysis and dependent failure. We have the safety validation specification and so forth. Also notice that we do have QM as well as A through D. So QM for everything is neutral except for impact analysis at the item level and hazard analysis and risk assessment. Both of them are at the I3 level. Some of the individual allocations or requirements are changed a bit. In here, we do have some I0s. We have less I0s under A than we did before. However, we do have a couple of blanks where, I guess we still have those blanks. We have a blanks in here, which we do not have in here. We have I1. I1, remember, says it shall be done by a person other than the person who is doing the creation of that document. So it has been beefed up. We have more information or more measures that we're doing, and probably the biggest one is the impact analysis, which we never had before.
Anyway, Greg, this is a good time to just talk a little bit about most efficient ways to do these confirmation reviews. Folks, think of them as confirmation reviews as part of sort of the, in the APQP, as we used to do quality of the element checklists, where you go in and make sure it was done and was done well, right? So some of the things the standard doesn't say exactly when somebody needs to do it, except you need to do it before you put the safety case together. Any guidance in the new standard on timing at all?
No, it's a similar thing. It's got to be done. It does say that you should do it as the work products are being developed. You shouldn't wait until the very end because things can change on that.
A lot of people were doing it. So, folks, one of the things we do, of course, is we say the ISO 26262, life cycle should be aligned to the APQP product release plan, and do that as you do the project reviews for APQP. You could do also these confirmation reviews and make it part of the same presentation. All the different types of alignment, Greg, that we talk about as we do it. Of course, if they wanted to, and they're doing a couple of different assessments, project assessments for the ISO 26262, the functional safety assessments, you could also maybe enlarge that to include confirmation reviews. You can mix and match it. And of course, this is something, especially confirmation reviews, we're adding to our auditor course as we're updating it.
All right. Okay, so that is the part 2 and the major points in part 2. If we look at part 3, again, one of the things that's immediately obvious is that we only have 3 clauses. We've dropped the initiation, which was the impact analysis, which got moved to part 2. And as in 2011, only hazards associated with malfunctions are considered. This is especially important because as we're getting into automated vehicles and that, people are also talking about safety at nominal. The hazards associated with system limitations, the basic nominal limitations, are analyzing using the SOTIF. SOTIF stands for Safety of the Intended Functionality. Now, as it turns out, it is still being developed. It hasn't been released yet, but it's ISO PASS. PASS is publicly available standard 21448, and this is when we're talking about automated vehicle, there are 6 levels of automated vehicles. This only goes up to and encompasses level 2. It doesn't get into a lot of the automation. The intent was to get something out that covers most of the vehicles that we have on the road, and then while they're working on the SOTIF standard for the rest. The SOTIF, the safety of the intended functionality, is different than malfunctions. Essentially says that the hardware and the software are doing what they were designed to do, but there is still threat of hardware or threat of a hazard. An example of that is there was an example of an automated vehicle that was on its own, and it struck a pedestrian who was not in a crosswalk, and it was dark, it was at night, and killed the person. Now, the thing is that after fact, they found that the system did see something there, but the algorithm that was used was not sensitive enough to identify that blob that it found through the different sensors as something that they had to react to. So they just continued going. So the program, the hardware and the software were doing exactly as they were told, but there was built into it this hazard because they were overriding the sensitivity because they didn't want the jerky drive motion, that it caused this hazard. So now they went back and they changed it and made it more sensitive, so they didn't. But this is an example of a safety of the intended function. It has, Part 3 now also has HARA for vehicles which were not in the scope of 2011. That's the trucks and buses as well as the motorcycles. Motorcycles are addressed in Part 12 specifically. Part 4, when we get part of the systems engineering, we get into the product development at the system level. If you're familiar with 2011, one of the things you could see is that we have moved from 7 different clauses to 4 clauses, which unfortunately, because it's an even number, we don't have a nice V shape. So we have just a 2 and a 2. With the 7 or any odd number, we would have a V shape, which gets with the V model.
Greg, for a second,
sure.
I think it behooves us to talk a little bit about Part 3. You know, not everybody has a Part 3, but maybe you can talk a little to them about the SEOC and how to think of it in context and out of context.
Yeah, the concept phase typically is, and even in the standard, the assumption is that if you are going to be developing in context, the OEM, the person who owns the item, would be the person doing the concept phase. But there are more and more organizations that are building, they're creating their product out of context. And the difference between in context is the OEM does the concept phase, the out of context is the person who is developing the element that's going to go into the item has to make certain assumptions. And so even though they are not the OEM, they still have to go through the thought process of the concept phase. They have to identify what type of product is their element going to go into, what are the possible hazards that could be at that item level, and then make assumptions as to the safety goals and the functional safety requirements. So we have found that even though that they're not an OEM, if they're doing a safety element out of context, they are really required to do at least go through the concept phase thought process.
When people are doing SEOCs right down to the sensor level, and hardware. So it behooves everyone to take a good look at it. At worst case, take your system level HARA, identify the safety goals, the safety requirements, and then deploy it down to your SEOC, I'll say.
Right.
Yeah. Okay, great.
Okay. The clause 4.5 in here used to be initiation of product development. The system level was renamed General Topics for Product Development, and that does not really have any specific requirements. The requirements are in 6, 7, and 8. Release for Production, which used to be in the Safety Validation, was now moved to Part 2. Which makes sense, by the way, because release for production essentially had to be signed by a member of management, a responsible person. So it makes sense that it would go into Part 2 when we talk about the management of safety. There is changes in the clause names and contents. This used to be technical safety requirements. It is now a technical safety concept, which does make sense because 2011 really, although it was in the clause, it didn't really spell that out as the clause name. But what happens is that this technical safety concept has been broadened. It includes the system architectural design as well as the identifications of the technical safety requirements and the allocation to the items or elements inside the architectural design. Item integration and testing, because we've dropped an extra one, is now system and item integration and verification. So they combine the two together. The same requirements are in there, virtually the same tables, but we now have them all consolidated. There is a new table at the clause 4.8, level of robustness at the vehicle level, looking at is the item that we are coming up, is it robust to expected noise variables? Now remember, the technical safety concept, once we get that done, is released to hardware and software. But before that, we need to have the system item and integration plan developed and then passed also to hardware and software people. The Part 5, the scaling factors, which were in 2011 Annex F, have been removed, and instead we have three annexes. We got example for the rationale that the objectives of Clause 9 meet in accordance with 4.2 are met. An example that the reliability budgeting assignment for an item consisting of two systems, and Annex F is an example of how to handle latent faults. If you are going to be using failure rates which are based upon field returns, that's given the name self-assessed failure rates, but the confidence level needed that when you are doing that is at 70%. In other words, it's not a point estimate, but it is a confidence level. Dedicated measures, for those of you who need to have a reflection on what is a dedicated measure, it is something that the design activities specifies either in a extended design feature, over design or something of that sort, or a requirement to the manufacturing and assembly. For example, sudden death or burn-in testing, or for that matter, safety characteristics. Those are considered dedicated measures. And those are required irrespective of the reliability calculation method. Remember, there are two methods to calculate the reliability. One of them is the overall fault tree, and the other one is the cut sets. You will have the dedicated measures always for single point faults, regardless of what the calculation is. And for latent faults, for the diagnostic coverage in latent faults, if it's less than 90%, there must be a dedicated measure. Part 6 is where we talk about Agile, and we said that Agile software development is allowed. There is a new Annex E. application of safety analysis of dependent failures at the software architectural levels. So we give some guidance on that. There is a new property called comprehensibility is required for software architecture. The implementation of software safety requirements which rely on freedom from interference. For example, in freedom from interference, if you have the decomposition of software, you need to have independence and freedom from interference, or of sufficient independence between software components. Dependent failures and their effects shall be analyzed in accordance with the Part 9, Clause 7, which deals with dependent failures. So it's spelled out. Now, it was always implied, because when you're doing it, it says if you're going to do decomposition or you're going to do it where you need the independence, you need to analyze dependent failures. Obviously, a lot of people were kind of tailoring that out. So now they specifically put it in. The safety analysis on architecture shall be carried out in order to show that the use of shared resources does not violate the freedom from interference requirements, and the software partitioning is supported by dedicated hardware features or equivalent means.
I think that's a interesting and important idea, that the software partitioning, you can't go back to a common element.
Yes, yeah, you got to have that. And on top of that, any software that implements partitioning has the same ASIL as the safety goal. So if you have an ASIL D safety goal that says a software dealing with the partitioning also is an ASIL D.
So you really can't do a decomposition there.
Well, you can. You just have to.
Yes.
But the software that's going to provide you the ability to do that partitioning has to have that same safety goal.
Excellent.
Right.
Folks, of course, what this drives is a hardware cost. When you talk about its dedicated hardware features.
Yes, right. There is some of that.
Yeah.
It also has a new table. I think has got put in because IETF now talks about embedded software. And so it talks about methods for deriving test cases for the testing of embedded software. Part 7, the next clause has an additional clause, the planning for production, operation, service, and decommissioning. Now, that has always been part of that, is that you need to plan. But now they spell it out. They said we got a separate clause that does that. That does include requirements, special characteristics, handling, configuration, as well as personnel competence. And now remember, we're talking about production, operation, service, and decommissioning. So it's not just the competence of the design activities where we always had that we had to have that competence. We're talking about this in the actual production activities. Now, of course, that does overlap with IETF, because IETF does say you have to have competency management for the entire development and production process. It includes traceability of special characteristics down to the production level and to the testing. You got to be careful because in IETF, they use traceability to talk about lot control, whereas 26262 traceability is of the function and goes all the way down to the characteristics and in the control plans. So we have that flow down. And it includes decommissioning, the planning of decommissioning. Production is pretty much the same. It includes control methods, specifically now spells out analysis of process failures, which are really part of the control plan. So that is consistent with the control plan. If you do, what are you going to do? The actions taken. And then the capability, which is also part of the 2011, that we need to do that. The third clause, operation, service, and decommissioning, does include field monitoring. One of the things that 2018 does is it doesn't put as much emphasis on field monitoring as 2011. 2011 had it in multiple parts. 2018 does not. It has it as part of Part 7. It doesn't do it as strong in Part 2 as 2011. Includes a service plan and change management in the field. So the expansion of change management, not only from the design activities in production, but how is that going to be handled in the field itself. Part 8 pretty much stands as it was before. It does have a couple of name changes. The qualification of hardware components is renamed to evaluation of hardware elements. And this has been changed in the qualification of hardware components. You're essentially looking at either doing it through testing or analysis. Here, they are classifying the hardware elements into 3 classes. Class 1 is only the data sheet is required, no evaluation. Class 2 is we need information to support analysis or testing. Both types are permitted. So this is essentially what was in 2011. And in Class 3, we need to have the information required for Class 2 and a safety case according to 26262 and argument for the prevention of systematic hardware failures. So we're actually getting to some into the little bit more. So this is for more critical items, Class 3.
So if you're making a circuit board, suddenly, with all the different components coming in, it gives you an idea who needs to really do that safety case, right?
Yes.
What is the definition there of Class 3, Greg?
I would have to look that up. I don't remember it off the top.
I'll look that up for you.
All right. Okay. All right. So that is there is 2 new clauses. Both are unique to truck and bus. Interfacing of an application that is out of scope to 26262. The thing is that we could have a base vehicle that has been developed with 26262, and then we have something that is interfaced with that base vehicle. So dump trucks, we essentially have the chassis and the truck itself, but now we start adding in other things that were not developed according to that, or trailers that we're putting on board. So it tells you how to interface that. Also, the integration of safety-related systems not developing according to 26262. So we could have systems not developed according to the standard to satisfy the level of functional safety needed for the integration into one that was developed according to standard. So this is more apt in the truck and bus than we do in the serial vehicles. And these specific situations, some manufacturer, supplier, or DIA requirements do not apply. So we would have to take a look at each of them individually. Part 8 also refers to the hazard analysis in context of the truck and bus. And when we look at it, performing the hazard analysis, we need to consider the type of vehicles, the type of base vehicles, the type of configuration, and how is the vehicle going to be developed? What is the vehicle operation? To this extent, we will have this will impact operational situations, hazardous events, and severity, exposure, and controllability classification. And there are very specific tables dealing with that and truck and the different base vehicles of the truck and bus. So it goes through and comes up with those directions on it. So truck and bus has a lot more detail that we have to consider when we are looking at the severity, exposure, and controllability. Part 9, there is clarifications. We have example architecture for coexistence of elements and decomposition of requirements. We have a new Annex B. We have a new Annex C, which talks about dependent failure initiators. That is a new term that was added, mentioned in the vocabulary, and so we have the definition or how to apply that. And we have adaptations of analysis for motorcycles and truck and bus. So that's 4.5, 9.45, and 9.46. Dependent analysis of dependent failures. There's clarification in Annex C. We have a checklist and a list of coupling factors which were added. And then the analysis of dependent failures shall have a level of detail and rigor suitably to demonstrate that we have independence level, required level independence or freedom from interference, depending upon the systematic coupling, which is dealing with ASIL, safety concept, and product complexity, as well as technology. For example, semiconductors could be prone to unintended impact. And so we need to consider that when we're analyzing dependent failures. Part 10 is pretty much the same. There is additional guidance on fault tolerancing, emergency operation, safe states for tolerant items, and fault tolerant interval and emergency operation. How does that all go together? So there is a lot more on fault tolerances. All right, 11 is a new clause. Now, the thing is, it's stated in the standard that it is applicable to all semiconductor components, whether developed in accordance with 26262 or not. So even though you're not doing it in 26262, you still need to understand what are these guidelines. And again, this is informative. It is guidelines. So it's not a standard, but it is applicable to all components. It brings in the concept of assumption of use. And so we have to define what are the different uses for these semiconductors, and all component level analysis are performed under these assumptions of use. We have to ensure compliance to it, or else we have to modify the component level analysis so that we do get compliance. Part 11 also talks about concept of intellectual property. It's a big buzzword in the semiconductor industry, the intellectual property. So how do you handle that, especially when you are utilizing different components together? What is the base failure rate estimation, and how do you do about it? How to do dependent failure analysis. Notice that we mentioned dependent failure analysis multiple times. That's because the writers of the standard felt that that was weak in implementation, so they want to make sure that people are looking at the dependent failures, especially if people are using decomposition, and decomposition does require independence of the individual pieces that we decompose to, the elements. So we need to do that. And the fault-tolerant injection for semiconductor component evaluation. How does one handle that?
Greg, a point on part 11.
All right.
So you have in a semiconductor, you have a system on a chip, right? And they bring that discussion into part 11, and they talk about safety analysis being done from a very low level, they call it elementary subpart level, to subpart level, part level, component level, and then system level, all within the chip. Because the semiconductor is fairly complex. And this is going to be very interesting to our semiconductor customers that, for those who argue, they don't have to do a system DFMEA, but there is a system DFMEA.
Right. That's right. When you put it all together, you essentially have a system on a chip. So you need to analyze it in that manner. Right.
Sequentially.
Right. Okay, the final part is part 12. It's the normative. So it is required adaptation to motorcycles. Now, all requirements 2 through 9 are in 26262 apply to motorcycles. However, some tailoring is required, and essentially that some of that tailoring is addressed in part 12. The requirements similar to part 2 are the safety culture, confirmation reviews, HARA, and verification and validation. But there are specific differences in some of these. There is a cross-reference table between part 12 and the rest of the ISO 26262, and that's part of Annex A. Now, part 12, the major adaptation of requirements applies to the development of the hazard analysis and risk assessments and the determination of the severity, exposure, controllability parameters. In a motorcycle, we have to look at hazard analysis and accounts for the dynamic behavior of motorcycles, which greatly differs from other vehicles. Other vehicles with 4 wheels, it's fairly stable by itself. Motorcycle is not. So we have the dynamic behavior. Motorcycle rider dependence to achieve controllability. So we have more so than in automobiles. And then the motorcycle specific operational situations and hazards identification. The writers of the standard feel that there was enough difference that they actually came up with a motorcycle safety integrity level. And so they developed this out of their HARA, and their specific HARA, and this is the mapping for the EMSL against the ASIL. So ASIL A, EMSL A is the equivalent of a QM in the ASIL, and B to A, C to B, and D to C. So this is how they would map that EMSL to ASIL. And there are specific data for severity and occurrence, that's Annex B, and controllability is Annex C. So it is different from one to the other. So motorcycles do have things that are different. However, there are, when you get into the actual testing and validation testing, they're pretty much the same. So looking at the whole thing all together, in 2011, there were 130 work products identified in the standard. Of those, 98 were unique. The difference between 98 and 130 was there were multiple documents that were identified during refinement or updating. For example, the safety plan was refined at least 2 or 3 times. The verification validation plan was refined a couple of times in that. So all that goes into the 130. With 2018, we actually have less unique work products identified, but of those, 106 are unique. And so we only have 7 of them that are duplicates in there. So I don't know whether you would look at that as positive or negative. We do have more unique work products when we go through now. By the way, this does not include, this only goes up to 9. It doesn't include Part 12, motorcycle, which has 11 work products. So there are additional ones if you're going into motorcycles. Of those, we can break that 113 into 2 segments. We have those that are unique to 26262, which are 72, and those which overlap with IATF. Now, this is actually a little less than 2011. 2011 had more of an overlap. This has some more uniquenesses with a lot of dependent failure analysis and the rest. But it also says is that 1/3 of the work products you're already doing if you are IATF certified.
So I think it's important to note here that anytime something new gets adopted in, lots of times it's done by a specialist group, right? And so there might be a specialist group doing these 41 documents that overlap with IATF, but eventually what we need to do is integrate in this work with the work that people are supposed to do, where they need to be educated into the ISO 26262, what they're supposed to do, and we do it once. We don't do it twice, because doing it separately actually, hurts quality, right?
Yeah,
and functional safety.
Besides ruining efficiency, because you're doing things over and over again.
Absolutely. It's costly to do it this way.
Right, and if you have multiple people do it, chances are that they're not all going to include the same information. So it's the reason why you need to identify it in your organization so that you only have one set of documents that you're dealing with. All right, and so that kind of takes us to the end of the review of what is changed and different about 2018 versus 2011. We do have books talking about integrated management systems and other books dealing with auditing that are available through ASQ Press. You can go ahead and take a look at it. We do provide functional safety services. We do training. We do consulting. We do product certification as well as personnel certification.
I just mentioned here something unique that we do, Greg, is come into your organization and help you train the people internally in terms of providing personnel certification for yourself. So that's something unique we do. And the other one, of course, is the ISO 26262 auditing course, and we're updating that to 2018 as we speak.
Right. We also have developing a functional safety tools courses. Take a step back at least. We could talk about our services, functional safety services. You probably have read it, that when it was up, even though we didn't have any voice. As part of that, as part of the overall training, we have come up with core tools course. These are tools that support the functional safety activities, including software FEMA, Faultry, DBPNR, and the DFMEA for monitoring systems response. We do have some public training of the 2018. This is from assuming that you did not from scratch. These are 5-day training courses that we also have an auditing the 26262 course as well. You can see the training schedule on our website at www.omnex.com.
So, Greg, I'll just point out that this course, both these courses, have been updated to the 2018 standard, and the one on top there is a certification course with an exam, and you can work your way from from entry level functional safety engineer to a senior. And there's also an auditing course, which is also very important with all the assessments, confirmation reviews, and audits that need to be done with 26262.
All right, and these, although we're doing it as open enrollment, we can deliver this class at your site. We could also do it in conjunction with a gap analysis or consulting and implementation assistance on that. We also have software that is supportive of 26262 as well as APQP, PPAP, and the rest of the different activities that you need to integrate in together. And we do also have AutoSpice courses. AutoSpice is consistent with 26262 as well as IETF. IETF does have embedded software requirements, and as part of that is the management of the performance of the software development, which many companies are utilizing automotive SPICE for. And so we do not only teach the course, but we also do assessments, creating test cases and auditing the different assessments. And we also have core tools for IETF, as well as other support activities, including APQP, MSA, SPC, FMEAs, and so forth.
So, as soon as you're done, Greg, we'll start with the questions.
All right.
And,
all right.
Go ahead.
We do have the additional ones, and this includes understanding the AutoSpice, the integration with 26262.
All right, folks, just go back. Let's go back, Greg. I'll start with the first question. It's not the first question on our list from our listeners today, but it's about how well does 26262 work with Agile? Why don't I take that question, Greg?
Sure, go ahead.
And then I'll also add to it Automotive SPICE back to you. So, folks, as you know, Omnex is very high on Agile. I don't know if you attended our Agile APQP. So we're talking about using Agile not just in software, but software, hardware, and systems development. So we don't believe ISO 26262 is extremely well compatible with Agile development. You just have to apply it as you do your Agile development, and you have your product list, and as you develop it Agile, you have to incorporate the ISO 26262. And I'll just add this, Greg, also Automotive SPICE, there's nothing stopping us when you're doing 26262, Automotive SPICE, and doing it in an Agile fashion. Okay, so let's take the first. In fact, that's also the first question, which is the software world embracing Agile Scrum. How is the new change taken into consideration? All along, the idea was that we would incorporate that into, especially in the software development. All right, question number 2. Does the standard mention anything about supporting external automotive software like diagnostic software? I'll let you take a look at that. Well, PC application establishing connection with ECU using diagnostic connectors like J1939, round connector using a RP1210 vehicle data adapter. are there any mandatory or advisory guidelines for that kind of software? Go ahead and take a look at that question, Greg.
No, the standard does not really talk about the external automotive software on that. Again, the whole question when you are doing that would be if you are using the external
as a tool.
Yeah. I'm trying to the specific terms. So you are when you are going through and identifying safety mechanisms, you could allocate that safety mechanisms to an internal element, or you can also allocate it to an external functionality. If you are using the diagnostic, I would assume that is like a safety mechanism. You're trying to determine whether there's something wrong, even though it's not online all the time. It is periodic. It would be you are using that external device as a safety mechanism for your internal system. So therefore, it would fall under the same type of requirements that you would want. Is that you would, if you're saying the safety mechanism is trying to detect a single point fault, well, okay, then it has the same ASIL as a single point fault, whatever the case may be.
But if it's being used, just as a tool, then the software qualification requirements in Part 10 would apply. So the key question is Part 8 is what I meant.
No, so, not really, because those tools are dealing with the development. This is not dealing with the development. This is dealing with the control, mitigating the effect.
There's a third type of software that people have which are not really, quite related to a safety mechanism, but it's there enabling. And I'm not thinking of a good example. Even in the development we're a part of, there's just a ton of software that's not directly linked to the, this product-related software. But this is, third-party software that helps enable development. So really used as a software tool. Sometimes it's even embedded right in the product. We'll take that offline.
Yeah.
Folks, the key decision is if it's a safety mechanism, then definitely 26262 applies. If it's a software tool, then Part 8.
That's right.
Qualification.
Yes. Yeah, that would be the case. Okay, the next one, if any existing regulations identify specific standards among the different types of autonomous vehicles? And the answer is no. We had mentioned the cybersecurity, which would be applicable, but also the SOTIF, safety of the intended function, which is, we referenced the PASS, which would be the only one that is actually dealing with autonomous vehicles, and yet that is still under development. So we really don't have a standard for autonomous vehicles.
Well, of course, we have in Part 1 through Part 5 classification of autonomous vehicles, and we all know ISO 26262 really comes into play. Let me just say this about SOTIF. I'm not even saying it quite right. If it ends up using the same tables as ISO 26262 in terms of control, I'll say is that you could just integrate it right into 26262. Definitely, I imagine the HARA could have both types of hazards, right? Anyhow, we will be doing a webinar when the SOTIF is going to get closer to getting released.
All right. A failure rate for individual failure rates of individual components is the recommendation change with respect to sources and all the different standards. No, there was no change on that. The example that was given as 62,380. That is still, those are publicly available or costly. You got to still pay for it. But defining the failure rates for individual components, you still have that. Now, it did say that if you are going to develop your own, then you should be using the 70% confidence bounds on the failure rate, not the point estimate. Is the requirement for software isolation be enforced by dedicated hardware features applicable to all ASIL levels? I really don't understand the question.
Remember, when we talked about software, we talked about the hardware.
Right.
When you partition,
you
need to have dedicated hardware. The question is it equally applicable for ASIL A versus ASIL D? And I think yes.
Yeah, it's what if the software has to be, if you have to have software that is independent and you are using a hardware feature to do that, yes, that would be applicable to that.
There's a couple more questions here.
I got another one here.
Okay.
From a this is about Agile.
Yeah.
You
already answered that.
Okay. The functional safety management, the safety requirements is named as a safety concept. What is the difference? Okay. The standard uses the word concept to mean requirements allocated to an element. So when you're at your functional level, you have a functional safety requirement, and the functional safety concept is that requirement which we're allocating to one or more elements. Same thing at the technical safety requirements, we're allocating the technical safety requirements to elements. Now, the only two elements that we essentially do are hardware elements and software elements. Once we get into the hardware and software development, we are really not dealing with the concept. We are really talking about the design. We're actually at that level, point itself. So I think that reason why in Part 6 they talk about safety requirements, but they don't talk about software safety concept, because software safety concept would be the software safety requirement allocated to itself. So it doesn't really make a whole lot of sense. It says no need to worry about tool qualifications. There are some tools promoted with 26262, like that means there are some tools promoted with 26262 support. Like that, it means that can we use any class of IDE compiler for a development? And you have to look at all the tools that you're using, and to say you can use any class of IDE compiler for your development, the answer would be unequivocally no. You have to look at it and say, does the IED compiler that you want to use, does it have the tool confidence level sufficient for your implementation on that? All right. We did have a couple of others. In Part 7, it says, how are we going to achieve decommissioning? Well, that's up to you. When you're designing your product, you need to design how is it going to be decommissioned. When you decommission, you're essentially saying, I have this system, this item, how am I going to make sure that it is going to be decommissioned, in other words, taken apart without any safety violations to the people who are taking it apart. In a lot of cases, this is very straightforward, especially nowadays with a lot of decommissioning is just pulling the pieces apart. What has changed for tool qualification? The tool, or there is very little that has changed in tool qualifications, other than it provides more definition of what each of the requirements are, when our methods are, has that detail. It identifies what you need to do to identify the tool that you are going to be qualifying. If I use Excel to generate test cases, do I need to qualify Excel? You have to ask your question, could Excel cause a violation of a safety goal if it messes up your tool cases, a test case? And the answer is, well, that depends. Depends upon, are you using a bunch of macros, or are you just using it for a storage and database type thing? If it is the one, then it's probably not, if it's just storage, probably not going to need a whole lot. If you got a whole lot of macros to develop these cases, well, you may want to take a closer look at it. Do these software diagnostic PC applications are used in the garage or for troubleshooting? We already took care of that. As I recall, in 2011, it was only for high-level ASILs. I don't know what that refers to. All right, I think we got all the questions that we have on there. So it's...
Folks, let me just thank Greg Greska, and hope you have enjoyed the webinar. He's our functional safety champion. And as you know, Omnex did one earlier this morning with Chinese translation and our Chinese SME supporting Greg in the webinar. And we do ISO 26262 globally, by the way, if you need to know. And thank you for joining us today. On behalf of myself, Chad Keimel, Greg Greska, and all of here at Omnex, thank you for joining us.
Yes, thank you very much.